Hi Guanming, this is Liam Beckman, and this is just a demonstration of the Voyager index project that was done as part of the capstone project for this last term. So I was in a group with two other members, and overall it was a very good project, and I think we're all proud of with how it turned out. And so this is the main page of the program, basically just a map with city markers over all of the cities within our database, and you can zoom in and out, and if you zoom in, the cities with lower populations show up. So Eugene, Salem, and Portland, for example. And if you click on any of them, it'll bring up this overlay, this pop-up overlay with the city name, location, and a nice little picture, as well as a zoomable map, should that be desired. And yeah, so over on the right we have city information, so population, elevation, air pollution index, all that. And this is all returned from the server running on Heroku. And here is the actual implementation I did with that. So basically whenever a city is queried, it goes to this city-search URL within the server. And so the search sent by the client has three pieces of information: the city name, the rank, and the ID. So these are the three kind of defining features for each city that allow us to uniquely identify each city within our database. Here we can have either a GET request or a POST request. It can handle both of them. And so here's our actual starting for our implementation or our interaction with the database. So if the search ID is not null, then part of the query for the database is where the ID of the city equals the search ID. So that's how we know what city we're looking at. Otherwise, if we do have an ID that is null or it's just not there, then instead of the ID, we search for names that are like the city name, and then order by population in descending order. And so this kind of has a whole thing to it. So the important part is this swimming pool function, which I'm very proud of. Basically, the swimming pool function takes a query, so the city ID or the name, and performs an action. And the action is defined up here. So basically, the important part is it ranks the cities, orders the ranking of the cities based on our own internal recommendations, and then sends the city rank back to the client. And that's only if the client actually asked for the ranking to be done. Otherwise, it just sends the results. It doesn't worry about all this ranking. And so if we do go to the swimming pool function, it's a nice little JavaScript async function, and basically we're connecting to a database running on my Raspberry Pi based on the configs we have set up in this file, and then we await the query. Once we get the results back, we get the rows. We release the client so it can do its own thing and connect to other queries, and then we basically if the action is not sent, then we just return the results. Otherwise, if an action was sent, previously described, then we actually perform the action with the results. And so let's go back here. And so this is really nice because we can also go to settings. And here we have a nice little command line interface here that I wrote, and I really like because it was written in Go. Which I've never done anything before, but I really like. So basically this sends it to, sends the command voy search with color for a city name of Portland. And so we'll go ahead and hit enter. Oops. And basically this sends this exact command to my Raspberry Pi where voy is installed, and then outputs the actual output of the program. So in this case, it's just a lot of JSON formatted data, color formatted, and yeah, so it basically allows you to interact with the database from the website. instead of having to install the program itself. And so, yeah, that's basically how the API search interface works with the database and the server. Yeah, let me know if I can provide any other information. Otherwise, have a great day.